4, 3.
Rotational forces act all around us, and upon us, every second. They power our technology, propel us into the future, and they define many of the natural laws that govern our universe. So what the hell is this thing? Let's say we plot this point on the 2D coordinate plane, and draw a vector from the origin to that point, creating a 30-degree angle between the vector and the x-axis. Another point is drawn with unknown coordinates but the same distance from the origin, but assume we know that the angle between its position vector and the x-axis is 120 degrees. This means that the angle between the two position vectors is 90 degrees. What linear transformation causes this? This is the rotation matrix. To derive this, we do the following. First, plot the unit circle and select a random angle theta, drawing a vector from the origin to a point on the circle that creates the chosen angle with the x-axis. Notice that the x-coordinate of this point is equal to cosine theta, and the y-coordinate is equal to sine theta. Pick a second angle phi, and draw a vector from the origin that makes that angle between the vector and the first vector. The angle between the x-axis and the second chosen vector should be theta plus phi. We have now rotated point P by some angle phi. The coordinates for this new point are shown here. Here is where the angle addition formulae come in. These are classic identities. You can derive them from Euler's formula or geometrically, but we'll take them as given. Now make the substitution regarding x and y with their respective trigonometric functions. Whenever you have a system of two equations and two linear outputs, you can package it into a matrix. Let's verify our derivation on our original problem. What are the coordinates of the second point if we rotated the first point by 90 degrees? Plugging in the angle and multiplying the derived rotation matrix with our original point's coordinates, we yield the coordinates of -1/2 and the square root of 3/2. We have determined our linear transformation to be defined by rotation, and we have derived the standard matrix for which rotation occurs in linear systems. Now it is your turn. Two vectors are drawn on the coordinate plane, with the angle between them being 165 degrees and the first vector's coordinates being shown. What are the coordinates of the point P final? Comment your guess and follow for more math education tutorials, quizzes, and quirks.